All right, so we are working on the Unit 4 Physics Study Guide here, and this video is going to be on the projectile questions. We got two questions here. One is going to be about a horizontal projectile going off of a cliff. The second question is going to be about an object launched at an angle. So we're going to start with this horizontal one. We got a car. It's driving straight off a cliff. So we got our little car here. We got a cliff. The cliff is 50 meters. And the car, I should say, is going at a velocity of 25 meters per second. This is going to be completely in the horizontal direction. And if we wanted to kind of draw a trajectory, it's going to go off and then make a parabola shape down to the bottom of the cliff. So what I know, I'm going to use this as my, y equals 0, x equals 0 point right there, right as it flies off. I know that my Vx is equal to, or I should say Vxi, my initial Vx, is equal to 25 meters per second. And that's not going to change because we're not using air resistance. And I know my Vyi equals 0 meters per second because it's going only in the horizontal direction. So from here, I'm going to write the equation I'm going to use to solve for how long it takes for the car to reach the bottom. I'm going to use YF, your final height, equals YI, your initial Y position, plus VYIT plus 0.5 times acceleration T squared. And I'm going to plug numbers in right away. Your final Y is going to be negative 50. You're going down 50. So we'll plug in negative 50 meters right there. Our YI, remember we started up here? That's 0. That's your 0 point. So 0 right there. Our VYI is 0. So 0T would also be 0. And then plus 0.5. Our acceleration is due to gravity. So negative 9.8 meters per second squared times t squared. This simplifies a lot. We could simplify it to negative 50 equals 0.5 times negative 9.8 would be negative 4.9 t squared. T squared equals 50 divided by 4.9, about 10.2. Or time is equal to about 3.2 seconds. That answers this first question. Oh my goodness, I didn't have that on the screen. My bad. 3.2 seconds. Next, it asks us how far did... Oh my goodness, I put the ball travel. All right, that's not a ball here. This is a car going off the edge. How far did the car travel? So when we're looking at how far the car traveled, we can use this equation over here. The distance it traveled in the horizontal direction is going to equal your velocity in the x direction times your time, which we just calculated down here. So we know the velocity is going to be 25 meters per second times our time, 3.2 seconds. Our delta x equals 3.2 times 25, 80 meters. So we could even add this over here. Boop, boop, boop. How far over did it go? 80 meters. I'll put it right here. 80 meters. What is the vertical velocity as the car hits the ground? So for this one, we know how long it takes to hit the ground. So we can use, our VYF, our final vertical velocity, equals Vyi, our initial vertical velocity, which is 0, plus acceleration times time. Start plugging things in. We're looking for Vyf equals 0 plus that acceleration is negative 9.8 meters per second squared times the time, 3.2 seconds. And it looks like you just have to multiply these two numbers and you get your velocity over here. 9.8 times 3.2, it's about 31.4. Oh, forgot the negative. Don't forget the negative. Negative 31.4 meters per second. So 31.4 meters per second in the downward direction. That's pretty quick. All right, so that is for our horizontal projectile question. All right, moving on to the next one. A marble is launched with an initial velocity of 17 meters per second and an angle of 25 degrees. Find the time the ball was in the air. Find the marble's maximum height and calculate the horizontal distance traveled. All right, so let's jump first into, let's draw a picture here. So we are just launching this. We'll launch it right at ground level. And it goes, pops off here at 17 meters per second at an angle of 25. Oh, I drew a little steeper. Angle 25 would be a little less. So it'll pop off here. It hits a maximum height and it's making a parabola shape. It comes back down. So what we want to get is, this is the max height. We'll call that H. And we want to get the distance, the horizontal distance, that's our delta X. And we want to get the time the ball was, or the marble was in the air. So first, let's try to get that time. But before we get the time, we have to break our vector down into components here. So let's break this down. 17 meters per second. If we want to get our x, Vx is going to equal 17 cosine of 25 degrees. Let me add the 25 degrees here. 17 cosine of 25 would give us about 15.4 meters per second. And we could also get our Vy. Vy would equal 17 sine of 25 degrees. 17 sine 25. That's going to be about 7.2 meters per second. All right, next we're going to throw it into this equation here. Yf, your final height, equals yi, your initial height, which, you're starting at, we'll call that 0, 0. You're ending at a height of 0 as well. Plus Vyi t plus 0.5 at squared. So we just said, this would be 0 meters. Your initial height is 0 meters. Unlike the horizontal projectile, you do have Vyi. This is your starting velocity. So this is your Vyi, 7.2 meters per second. 7.2 meters per second times your time plus 0.5 times your acceleration. This is gravity. So negative 9.8 meters per second squared times t squared. So simplify this a little bit. 0 equals 7.2 t minus 0.5 times negative 9.8 is minus 4.9 t squared. We can divide both sides by t. 0 divided by t is also 0. So we could just say 0, divide both these by t, and you get 7.2 minus 4.9 t add 4.9t to both sides, and then divide both sides by your 4.9. 7.2 divided by 4.9 gives about 1.47 seconds of time in the air. 1.47 seconds. All right, next we got to find the max height. The trick you need to know about this question is once we launch and we hit that max height, the vertical velocity is 0. So this is the point where the vertical velocity is 0. So let's start plugging these in here. Here we'll do it in a different color. VYF squared equals VYI squared plus 2a, and this is going to be times the difference in height. So I'm just going to say this is h, that max height right there. So we just said that's when this is 0 equals VYI squared. This would be 7.2 squared plus 2 times a. Remember, a is your gravity. So 2 times negative 9.8 would be negative 19.6 times h. All right, we're going to do some math right here. 0 equals 7.2 squared is about 51.8. We'll leave it at that. We'll round up 51.8 minus 19.6h. Add 19.6h to both sides, so you just get 19.6h over here equals 51.8. And we are going to divide that by 19.6, and you get about, your maximum height is about 2.6, and our units would be meters. So find the marble's maximum height, 2.6 meters. And lastly, calculate the horizontal distance the ball traveled. These horizontal questions are always the easiest because if you're asking about distance, we assume that this velocity stays the same. So all you have to do is get your delta x. It equals your velocity in your x direction times the time. So delta x equals 15.4 meters per second times your time. 1.47 seconds equals 15.4 times 1.47 seconds, about 22.6 meters. Let's box both these to make it look nice. And we'll write that up here. 22.6 meters. All right, so that's it for this video. We just had 2 projectile questions.